This cab had no firebox, no boiler, no coal, no water, no fireman shoveling fuel into a fire. One engineer operated the Gg1. From this cab, a single person controlled 4,600 horsepower of continuous power and could call on over 8,500 horsepower for acceleration. The Gg1 could out-accelerate any steam locomotive on the Northeast Corridor. It could sustain over 100 miles per hour with a heavy train. And it did all of this with controls so different from steam operation that an experienced steam engineer had to learn the job almost from scratch. The Gg1 hauled the Broadway Limited, the Congressional, the Senator, the premier passenger trains of the eastern United States. And it changed what it meant to be a locomotive engineer. This is what it was like to operate the most durable electric locomotive in American history. The controls, the skills, the fundamentally different experience of driving a locomotive that drew its power from a wire overhead. No fireman, a new kind of railroad job. The Gg1 was operated by a single engineer. There was no fireman in the traditional sense, no boiler to manage, no fire to maintain, no water to monitor. The Gg1 drew its power from the overhead catenary wire continuously. The locomotive did not generate its own power, so there was no power plant to operate. This was a fundamental change in the nature of locomotive operation. A steam locomotive was a self-contained power plant that required constant tending. The Gg1 was a power consumer drawing from an external supply. The engineer's job shifted from managing a machine's internal state to managing the train's movement through the electrified territory. But this did not make the Gg1 simple to operate. The locomotive had its own demanding skills: managing tractive effort to avoid wheel slip, handling the heavy, high-speed passenger trains the corridor demanded, and operating within the electrical limits of the catenary system. What it was like to drive a Gg1 is the story of how electric traction changed the locomotive engineer's job, from the physical, two-person craft of steam to the precise, single-operator skill of high-speed electric railroading. The Gg1's primary control was the controller, a handle that regulated the power delivered to the traction motors. Where a steam locomotive used a throttle to control steam flow, the Gg1 used the controller to regulate electrical power from the transformer to the motors. The controller moved through a series of positions. Each position connected the traction motors to a different transformer tap, delivering progressively more voltage and therefore more power. The engineer advanced the controller through these positions to accelerate the train and reduced it to decrease power. Advancing the controller had to be done with judgment. The Gg1 could deliver enormous power, far more for short periods than its continuous rating. Applying too much power too quickly, especially on starting or on slippery rail, could cause the driving wheels to slip. The engineer managed the controller to apply power smoothly, building tractive effort without exceeding the rail's grip. Wheel slip on a Gg1 was managed differently than on a steam locomotive. The engineer monitored the locomotive's behavior and the ammeters that showed traction motor current. A sudden change in current could indicate the onset of slip. The engineer would reduce the controller setting, allow the wheels to regain grip, and then reapply power. The ammeters were the Gg1 engineer's primary feedback instrument. They showed the current flowing to the traction motors, which directly indicated how hard the locomotive was working. The experienced engineer read the ammeters continuously, using them to manage power application, detect problems, and operate the locomotive within its electrical limits. Starting a heavy passenger train from a station was where the Gg1's acceleration capability showed. The engineer advanced the controller, the traction motors delivered their enormous starting torque, and the train accelerated faster than any steam locomotive could manage. The Gg1's ability to get a heavy train up to speed quickly was one of its defining operational advantages on the busy corridor. At speed, the Gg1 was smooth and stable. The quill drive that isolated the traction motors from the wheels gave the locomotive an excellent ride at high speed. The engineer could sustain over 100 miles per hour with a heavy train, holding the controller at the appropriate setting while monitoring the ammeters and the track ahead. Power was only half the job. Stopping a heavy, high-speed passenger train was a skill that defined the Gg1 engineer. The Gg1 used the standard Westinghouse air brake system. The automatic brake valve controlled the brakes on the entire train. The independent brake valve controlled only the locomotive brakes. The engineer used these to manage the train's speed and to bring it to precise stops at station platforms. Braking a high-speed passenger train required anticipation. A Gg1 hauling a heavy consist at 100 miles per hour had enormous momentum. The engineer had to begin braking far in advance of the stopping point, making controlled brake applications that slowed the train smoothly without subjecting the passengers to harsh deceleration. Station stops demanded precision. The engineer had to stop the train with the cars positioned exactly at the platform, within a few feet of the correct position. On a heavy passenger train at speed, this required reading the approach, beginning the brake application at the right moment, and modulating the brakes to bring the train to a smooth, precise halt. And passenger comfort was a constant consideration. The Gg1 hauled premier passenger trains where the quality of the ride was part of the service. Harsh braking, jerky acceleration, or rough train handling reflected poorly on the railroad. The engineer's skill was measured not just in safety and schedule, but in the smoothness of the operation that the passengers experienced. The Northeast Corridor was one of the busiest and most heavily signaled railroad lines in the world. The Gg1 engineer operated under constant signal indications, managing the train's speed to comply with signals, anticipating restrictions, and maintaining the schedule on a line where many trains operated in close succession. The corridor was equipped with cab signaling, a system that displayed signal indications inside the cab, supplementing the wayside signals. The Gg1 engineer monitored the cab signals continuously, responding to changing indications and operating the train within the speed limits the signal system enforced. The combination of high-speed, heavy trains, dense traffic, and demanding schedules made the Gg1 engineer's job one of the most respected operating positions on the corridor. The engineer managed a powerful locomotive at high speed through complex signaled territory, maintaining schedule and ride quality on the premier passenger trains of the eastern United States. For the engineers who came from steam, the Gg1 was a different world, and learning to operate it meant unlearning the habits of a lifetime. Most of the engineers who operated Gg1s in the early years had come from steam locomotives. They had spent their careers managing fireboxes, monitoring boiler pressure, coordinating with firemen, and operating self-contained steam power plants. The Gg1 required them to set aside almost all of that. The most obvious change was the absence of the fireman. A steam engineer had always worked with a partner who managed the boiler. The Gg1 engineer worked alone. The coordination that had defined steam operation, the constant communication between engineer and fireman, was simply gone. The engineer was solely responsible for the locomotive. The deeper change was the absence of power plant management. A steam engineer was always aware of the locomotive's internal state. The fire, the steam pressure, the water level. These determined what the locomotive could deliver. The Gg1 engineer had no such concerns. The power came from the wire. As long as the catenary was energized, the locomotive could deliver its full power on demand. The engineer's attention shifted entirely to the train's movement and the territory. The controls themselves required relearning. The throttle of a steam locomotive and the controller of a Gg1 did different things in different ways. The reverser of a steam locomotive had no equivalent on the Gg1. The skills of firebox management and boiler coordination were useless. The engineer had to learn a new set of skills focused on electrical power management and high-speed train handling. Engineers who made the transition described it in mixed terms. The Gg1 was easier in many ways. No physical fire tending, no boiler anxiety, no firemen to coordinate with. But it was also faster, more powerful, and operated in denser, more demanding territory than most steam operations. The corridor's high speeds and tight schedules created their own intensity. And the Gg1 carried a different kind of responsibility. It hauled the premier passenger trains of the eastern United States at high speed through densely populated territory. The consequences of an error were severe. The engineer operated under constant signal indications, maintained demanding schedules, and carried hundreds of passengers at over 100 miles per hour. The job demanded total concentration. The engineers who mastered the Gg1 became some of the most respected operators in American railroading. They had learned a new craft, high-speed electric railroading that bore little resemblance to the steam operation most of them had started with. The Gg1 was the locomotive that taught a generation of engineers what modern railroading would become. The Gg1 served for nearly 50 years. Engineers who began operating Gg1s in the late 1930s could have operated them through the entire Pennsylvania Railroad era, the Penn Central era, and into the Amtrak era. The locomotive outlasted the careers of most of the engineers who ran it. Over those decades, generations of engineers learned the Gg1. The locomotive's controls and operating characteristics remained essentially consistent across its entire career. An engineer trained on a Gg1 in 1940 could operate a Gg1 in 1970 with the same fundamental skills. The locomotive provided a stable, consistent platform across an extraordinary span of railroad history. By the time the Gg1 reached the end of its career in the early 1980s, the engineers operating it were running locomotives that were over 40 years old. The Gg1 had become a legacy machine, beloved by the engineers who knew it, respected for its durability and its power, and increasingly anachronistic as newer electric locomotives arrived on the corridor. When the Gg1 was finally retired, the engineers who had operated it lost a locomotive that many considered the finest electric machine they had ever run. The Gg1's combination of power, smoothness, durability, and straightforward operation had made it a favorite among the operators who knew it. Today, the Gg1 survives only as static museum displays. The PCB contamination in the transformers prevents any Gg1 from operating. The engineers who actually drove Gg1s in revenue service are now elderly, and the operational knowledge they carry, what it was actually like to run a Gg1 at speed on the corridor, is becoming history. Unlike the big boy, no Gg1 will ever operate again under realistic circumstances. The chemistry of the transformers makes restoration prohibitively difficult. The experience of driving a Gg1, the controller, the ammeters, the high-speed corridor operation, exists now only in documentation and in the memories of the engineers who lived it. What it was like to drive a Gg1 was the experience of operating one of the first truly modern locomotives. Single-operator electric power, high-speed corridor railroading, the precise, demanding skill of managing a powerful electric machine at speed through busy territory. The Gg1 was where American railroading first learned what the future of locomotive operation would feel like. The big boy was the peak of one era of railroading, the massive, two-person, self-contained steam locomotive. The Gg1 was the beginning of another, the powerful, single-operator, externally powered electric locomotive. Driving them was as different as the machines themselves, and the engineers who operated both lived through one of the great transitions in the history of their profession. Driving a Gg1 was the experience of operating American railroading's most durable electric locomotive at the dawn of modern high-speed railroading. A single engineer. 4,600 horsepower drawn from a wire overhead. The precise skill of managing a powerful electric machine through the busiest corridor in the country. This is part 2 of our From the Cab series, exploring how the most significant locomotives in American railroad history were actually operated. Companion to our What's Under the Hood series on the engineering inside each locomotive. Both series are linked in the description. Part 3 covers driving the EMDF unit, the diesel locomotive that consolidated 4 locomotives into a single cab and turned the steam engineer's craft into the modern locomotive operator's profession. Subscribe so you do not miss it. There are more locomotives to examine. There are more cabs to climb into. We will keep telling the story of how the machines were actually operated by the people who worked them.